Okay, so let's learn about how these waves travel through Earth. Okay, the first thing that we need to know is what the layers of Earth look like. Um, there are different layers to Earth. The upper crust is solid, and then you have the mantle, which is kind of solid, but like not super solid, and then the core, which is definitely liquid. Okay. Uh, these terms here, like mesosphere, outer core, inner core, asthenosphere, lithosphere, don't worry about these. It doesn't matter. Um, um, Nobody cares. Um, so I only say that because like I don't. Okay, I'm gonna start over because I shouldn't be this negative. You know what? Whatever. It's okay. Um, I'm not a geologist. I don't find geology very particularly interesting. So I'm gonna be a little bit negative about it, but that's okay. But anyway, just know that like all this stuff is we can essentially say that this is solid and this is liquid. The middle of Earth is a liquid, and then everything else is a solid, more or less. Um, and that's all you need to know. Okay. So if we took a slice of Earth and we then had an earthquake happen, and we were to take a picture of the ways that or the paths that the waves take, we would see that a P wave, P is in primary, wave travels through all of the Earth. It can go from one side of the planet directly to the opposite side of the planet. The reason is because remember, P waves can travel through any type of matter, solid, liquid, or gas. So it can travel through the solid space and the liquid space. The interesting part is you're probably wondering, well, why is it curved? Why do these curve? Well, these waves, P waves and S waves, so all seismic waves really, travel faster through denser materials. If you think about like what's more dense, a liquid or a solid, most of the time solids are more dense than liquids. Okay, so if the most dense material is on the very upper crust, that means the waves on the very surface of the planet are going to be moving faster than the waves that are down here. Essentially, that just causes all of these waves to want to get to the surface as soon as they can, so that way they can travel faster. Okay, so seismic waves curve because they travel faster as they get closer to the surface. And then here, like you can see that this one bent, this one too. Anytime that it goes through the liquid core, that's called, and like it like bends, that bending is called refraction. You actually do not need to know that, but I just told you, so now you know. Okay, so refraction is whenever a wave bends as it goes into a different surface or into a different medium. Like, have you ever heard of like light refracting, or yeah, like if you've ever looked at something in water and it looks weird, like you stick your finger in water and it kind of looks like your finger separated, but like it didn't. That's because of refraction of light. It just changes direction when it goes through different mediums. That's all that means. Anyway, you don't need to know that. The last thing that I need to point out here is that a P wave has what are known as shadow zones. They are pretty small, relatively speaking. They go from, I'm not going to tell you the specific zones because it's, again, too many details. But essentially, the word shadow zone just means places that you cannot feel an earthquake. Okay, so scientists were actually able to figure out what the inside of Earth looked like based on where shadow zones were. And they were able to pinpoint the location of earthquakes based on having like different sensors all over the planet. Like there were some here and here and here. And they would say, okay, I could feel it, but I couldn't feel it. And this one could feel it. And then they were able to say, okay, these couple ones were in the shadow zones, but these ones were over here. And so then they can do some reverse engineering to figure out where those waves originated from. It's very complicated. I could not figure that out. But yeah, that's how they do that. So shadow zone. Shadow zone, that is where you cannot feel a quake. Okay. S waves, their X-rays are going to look a little bit different. S waves, if you remember, cannot travel through liquids or gases. S waves can only travel through solids. So we said that essentially only the crust and the mantle were more or less solid. The middle, the core of Earth is liquid. So the S waves, which are the transverse waves that travel like this, will not reach the other side of the planet. Only one side of the planet can ever feel an earthquake, can feel the secondary waves from an earthquake. So the shadow zone of an S wave is huge. It's like the whole side of a planet. However, these do travel more slowly, and these are often the more destructive ones because it's like actually causing buildings to slide around and move and do things that they were not designed to do. In California, we've gotten pretty good at building buildings that are able to move because we have heard California has a pretty long history of earthquakes and stuff. So yeah, but S waves travel slowly, and they also do the bending thing. So yeah, put together, it would look like this. So on one side of the planet, the people in the seismographs would feel both the S and P waves. On the other side of the planet, you might feel P waves if you are kind of like on the opposite side, like over in this zone, you can feel P waves. But then remember, there are those pockets on either side that cannot feel P waves. So this is a P wave shadow zone. This is a P wave shadow zone. But the whole other side of the planet is an S wave shadow zone. Okay. How do we get these readings? How do we know these things? We use things called seismometers, which record the vibrations from earthquakes. Essentially, it's just a weight on a string, or a spring rather, that just jiggles, and the squiggles are what we call a seismograph. If we look at a seismograph, we have an example here. The Earth is always kind of grumbling, so you have noise, right? But remember, a P wave comes first, and it is a very loud, very sharp wave. So the seismograph will pick that up first, and then the S waves, the much slower moving waves, will come afterwards. So whenever you see a seismograph, you will get an initial spike that is your P wave. Then everything after that, all the spikes after that, are just S waves. I don't know why they wrote it that way, just S waves. And they will repeat over and over because as we saw in the video, like this one, the Earth kind of just jiggles back and forth for a little while, causing lots and lots of damage. Yep. All right, and that is all about earthquakes.